are going to learn about redox reactions. Also, we will see what is corrosion and rancidity of food. So let us start. Redox reactions. Now, if you see the name, it suggests it is redox. Now, what is red and ox? Red stands for reduction and ox stands for oxidation. Now, what is a reduction and an oxidation? Reduction and oxidation, as the name itself suggests, oxidation is gain of oxygen. So obviously reduction is reverse of it, that is loss of oxygen. Also, reduction and oxidation can be defined by in the term of hydrogen. So this is loss of hydrogen. So obviously this is gain of hydrogen. Usually most of the reactions are redox reactions, but how to tell if there is no oxygen or hydrogen in the reaction? In that case, we should always go for a standard rule, that is oxidation is loss of electrons and reduction is gain of electrons. This is loss of electrons and this is gain of electrons. So though there are three definitions for reduction and oxidation, the best will be to see the loss of electrons and the gain of electrons. Now let us see how. In oxidation reduction reactions, electrons move between the atoms. Now how does it happen? Let us suppose we have two elements, that is element A and element B. Now in a reaction, obviously the electrons will transfer from one element to the other. Now when this happens, there is an electron transfer. So we can see that there is here we can see there is loss of electron, and for B there is gain of electron. Now if we see our definition, which one is reduction and which one is oxidation in this case? We can tell that gain of electrons is reduction. So B is being reduced and A is being oxidized. On a contrary, we also say that the one which gets reduced is an oxidizing agent. Now, why an oxidizing agent? I will tell you that. This is a reducing agent. See, it's very simple to understand. Like how LIC agent comes to us and gives us an LIC policy, and he himself won't have any LIC policy. He will only give it to us. So an LIC agent gives LIC policy to us, and in turn he won't have. Similarly, an oxidizing agent will gain the electron and itself it gets reduced. A reducing agent loses electron and itself gets oxidized. It's a little reverse here. So the one which gets oxidized is called as reducing agent, and the one which gets reduced is called as oxidizing agent. It will itself get reduced and oxidize the other one. This itself will get oxidized and reduce the other one. So it's an agent. Now, to remember, reduction is gain of electrons. oxidation is loss of electrons. This is actually, reduction should be something reducing. Then why gain? Because you can remember that it is reduction of charges. Oxidation is loss of electrons. This is gain of charges. So at least if you can remember one, you can do the other one. For this, we have a simple acronym to remember. It's oil rig. Oil is oxidation is loss. Oxidation is loss. So we can say that it is oil. So here we will write oil. And the other one can be rig. So if you know the oil rigs where they take out oil, so reduction is gain, oxidation is loss. So this is oil rig. So just remember the third definition, that is oxidation is loss of electrons, reduction is gain of electrons. Now let us see some examples. Now let us see an example. In this case, Na and Cl is becoming NaCl. Now how does it happen? Na is a neutral element. Cl is another neutral element. From this, there is an electron transfer. So it becomes, Na becomes Na plus, and it will give away its electron, and Cl will become Cl minus. This in turn will become Na plus and Cl minus, because neutral atoms do not attract, but once they get the charge, the positive and the negative will attract each other and it will form a compound. Now in this compound, we can see that there is a gain of electron and there is a loss of electron. So this type is an example for redox reaction. Now how can we tell which one has reduced and which one has oxidized? Always remember that neutral elements always have a charge of 0. Now Na has a charge of 0. Cl also have a charge of 0. When it becomes NaCl, Na gains a positive charge and Cl, because it has taken one electron, gets a negative charge. These are electrically neutral and they have charge. Now if you see, when this reaction is occurring, Na, which was 0, it has lost one electron, and loss of electron is called as oxidation is loss. That is oxidation. Here Cl was 0 and it has gained an electron and it became -1. And we know that reduction is gaining. So this one has reduced and this one has oxidized. So Na has oxidized and Cl has reduced. So this is an example of reduction reaction. Now let us see one more example. Copper plus oxygen, on heating it becomes copper oxide. Now in this case, always remember a rule. Neutral elements have 0 charge and compounds will have charged ions. Always remember this rule. Now in this case, this is in elemental form, so its charge is 0. This is in elemental form, so its charge is 0. Now this has become a compound. Compound will have charged ions. Now we always know that oxygen has a charge of 2- and copper has a charge of 2+. Now if you see here, copper from 0 to it has changed, that is it has lost electrons and the charge is 2 plus. That means it has lost electrons and gained a positive charge. Whenever you have loss of negativity, you gain positivity. So when there is a loss of electron, it becomes oxidation. When there is a gain of electrons, that is in oxygen, it has become 0 to 2 minus, that is it has gained 2 electrons, it is reduction. So this is an example for redox reaction. Now in this case, can you tell which one is the oxidizing agent and which one is the reducing agent? Tell me. Now let's see one more example. Let us see the first one. Zinc plus HCl gives H2 plus ZnCl2. Now in this case again, zinc is a neutral element. A neutral element, so it has a 0 charge. So let us put a 0 here. HCl. In HCl, chlorine always has a -1 and in turn H will have a +1. Then coming to this, in products again we have some single element which is neutral again, so it's 0, and in ZnCl2, Cl is always minus, and if you don't know the other elements charge, you can simply see this one is -1, there are 2 atoms, so the total charge becomes -2, and overall it should be neutral. So if this is on a whole 2 Cl minus, 2 Cl's are made, Cl minus and Cl minus are making 2 minus, then Zn will be balancing it, so it will be 2 plus. So you can see that Zn has become 0 to +2. It has gained positivity. That means it has, due to the loss of electrons, it has gained positive charge. So this is zinc has oxidized. Here H, if you see, hydrogen has gained electrons. From +1 it has become 0. It was positive first, it gained these electrons which are negative and it became 0. Gain of electrons is reduction. Now here if you see chlorine here also it's -1, here also it's -1, so there is no change in chlorine. But as a whole, because hydrogen is associated with chlorine, we say that HCl has reduced to H2. Now which one is the oxidizing agent, which one is the reducing agent? The one which is getting oxidized is called as reducing agent. The one which is getting reduced is called as the oxidizing agent. Now one more for you. CH4, that is methane, plus oxygen gives CO2 plus H2O. Pause the video and find out what is the oxidation number change. These numbers what we are writing, 0, +1, -1, okay, these all are called as oxidation number. These are called as oxidation numbers. Okay, now find out what will be the change in the oxidation numbers and which one is getting reduced, which one is getting oxidized. Now some quick rules for redox reaction. All combustion reactions, we have already seen the combustion reactions are the ones where oxygen is added. All combustion reactions and single displacement reactions, and the type of reactions we have already studied 4 types, in which the third type was single displacement reactions, are redox reactions. So wherever you see a combustion reaction, that is a reaction with oxygen or a single displacement reaction, definitely they are redox reactions. Double displacement reactions, we have seen the 4th type are double displacement reactions, like we have seen the acid base neutralization, and we have also seen some precipitation reaction. These are not redox reactions. These type of reactions are not redox reactions. Then one point which you should always remember is wherever you see pure elements in a reaction, that is definitely a redox reaction. So these are some quick points which you should remember. So questions which are asked in the board exams are usually, you have to identify whether it's a redox reaction or not. And then if it is a redox reaction, you have to find out the oxidizing agent and the reducing agent. So these are some quick points which you should remember. If you see any pure element, it is definitely a redox reaction. Some more examples for you. This is an exercise. So by seeing the reaction, you should be able to tell whether it's a redox reaction or not. First one, Zn plus Cl2 gives ZnCl2. Here you can see there are neutral elements. So let us keep our points ready. So in this, we have pure elements. Zn is there, Cl is there. So this is definitely a redox reaction. Then HgO, Hg plus O2. Again, in this reaction, we have pure elements, also oxygen is there, so it is a redox reaction. In this, you can see it's ethanol plus O2. So wherever there is a combustion reaction, it's a combustion reaction. Where it is an addition with oxygen, it's a redox reaction. Now coming to this reaction, this is AgNO3 plus NaCl gives AgCl and NaNO3. There are no pure elements, and you can see there is a double displacement, so it is not a redox reaction. You can see this one, the second point. In this, again, it's a combination reaction, so you have to find out the different oxidation states and find out whether it's a redox reaction or not. Again, by seeing you can tell this one, because there is a pure element, this is a redox reaction. So some reactions you can directly see and tell. Now in these, please find out for the redox reactions which one is the oxidizing agent and which one is the reducing agent. That's your exercise. Now where do we see these redox reactions? I mean, where do this oxidation occurs? Where do this reduction occurs? See, we have seen many type of corrosion, like for iron, when we keep it outside, it rusts. We all know that. And many of the girls wear anklets, silver anklets or silver articles. They also become black in color. That is also a type of corrosion. Then we have the copper vessels or copper bottles. It becomes green in color. All these are examples of corrosion. So let us see what exactly is corrosion. Corrosion is the process in which surface of metals, it usually occurs only in metals because they are more reactive. The process in which surface of metals are attacked by atmospheric agents like oxygen, carbon dioxide. Here water means the moisture in the air, etc. What happens to the metals? It reduces the strength, and also it will become dull in appearance. The appearance will also be affected. For example, iron nail, if you see, when it reacts with the atmospheric oxygen and moisture, it becomes iron oxide. Now this process is called as rusting. We all know that it is called as rusting, and the compound formed is iron oxide and the color is reddish in color. Silver, I told you the silver anklets, they become black in color because it reacts with the sulfur which is present in the air, and it forms silver sulfide which is black in color. And copper vessels also, they combine with carbon dioxide and water, that is again moisture, and it forms copper carbonate because there is carbon dioxide, so it forms carbonate compound and it's bluish green in color. These are all examples of corrosion. Remember, we say rusting only for iron. We don't say rusting of silver or rusting of copper. Rusting word is used only for iron, whereas corrosion is a general word which is used for all the three. Now, how to prevent corrosion? To prevent corrosion, you might have seen, what do we do to the grills of our doors and all? We do painting, Also, to the cycle chain, if it is rusted, what do? We grease it, oiling. Alloying is one more process. Then galvanization, that is giving a coating of zinc. Then chrome plating. There are many methods to prevent corrosion. Coming to the last topic, that is rancidity. Now, yes.
No, I'm hungry.
Go eat some snacks.
Yeah.
Now, rancidity is when you keep some oily food. Yeah?
It smells oily.
Oh, okay, keep it. Now, see, when you keep some food containing oil or fats, when you keep out for a very long time, was it open for a long time?
Yeah, I opened it yesterday.
Okay, so when you keep it for a very long time, it gives a foul smell of oil and also it tastes bad. Don't eat this.
Then what should I take?
You can take something else.
Yeah, I will.
So when food containing oil or fats, when they are kept out for a very long time.
But this is only filled half.
Yes. So they are called as rancid. The food gets rancid. Okay.
Oh.
And so what to do to prevent rancidity? What's inside?
Chips?
Okay. Is it full?
No.
Just see. It's empty, right? It's
This full, half is full, half is empty.
yeah. So it's half empty. Why? Because it has nitrogen gas inside. Why do they fill nitrogen gas inside? Are they
Why?
cheating us?
Why not air?
See, air again contains oxygen which can oxidize the food just like that. Nitrogen will cover the food and it will protect the food from getting rancid. So, you can have chips. So, rancidity is when fat or oil containing food materials are left for a long time. They get oxidized by atmospheric chemicals. Their taste and smell changes. The prevention is keeping the food in airtight container or packing with antioxidants like nitrogen gas. Now oxidation is becoming the food becoming if you take an apple, oxidize means the color changes or the smell changes or the taste changes. So to avoid oxidation, it is called as antioxidant. Now antioxidants like nitrogen gas is flushed into packet of chips so that your chips packet is still fresh whenever you eat it. And also one more method can be refrigeration. So this is about redox reaction, oxidation, rancidity and corrosion. Thank you.